Hello everyone, welcome back to Chemistry 24 into 7 series. In this series, we have been exploring the solution for previous year competitive exam papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. So this is the problem from GATE 2025. As per this question, this alkene react with hexylborane and followed by carbon monoxide and water. In third step, react with sodium acetate and hydrogen peroxide, which produce intermediate X. This intermediate X react with LDA and trimethylsilyl chloride and followed by phenyl sulfinyl chloride. In third step, react with metachlorobenzoic acid. In fourth step, when we heat that mixture that produce product Y. So here there are four options are given. Let's solve together which one is the correct option for this question. So this reaction contains lot of magnetic details, so don't skip this video. If you anyone skip this video, it's really hard to understand the magnetic detail in later stage. So let's moving to the solution. The first step of the reaction is hydroboration reaction. So here you see this alkene going to react with hexylborane. So initially this alkene going to react with hexylborane. So this reaction undergo by Syn addition as well as which follows anti-Markovnikov rule due to the steric reason. Since here you see this group is highly sterically crowded, so now, as per this rule, this hydrogen going to add this carbon. In case of borane, you need going to take this terminal carbon due to the steric crowding. So here you see now this hydrogen takes here and this boron going to add this terminal carbon which produce this corresponding intermediate species. Now this intermediate species boron atom has one more hydrogen, which means that one more hydroboration going to takes place. So for that, you just redraw the structure like this. So this is the conformational form. So here, this boron and this hydrogen unit going to add this alkene by same phase, which means that syn phase. So here, this hydrogen takes this position due to the steric crowding. This boron going to take this position, so which produce this corresponding intermediate. So here we should note it down the stereochemistry of these two hydrogen atoms. So here this hydrogen atom add this alkene by top phase of the alkene. Therefore, so here you see this hydrogen takes the top phase. In case of here, this is syn addition. This boron atom also going to add this alkene by top phase, which makes that this hydrogen goes bottom phase. So here you see now this hydrogen going to bottom phase. So now this intermediate in subsequent step react with carbon monoxide. So this reaction is alkylborane carbonylation. So carbon monoxide now attack this boron atom. So here you see this negative charge now attack boron atom, which produce this corresponding intermediate species. Now this pi electron move towards the oxygen atom. Now this carbon get positive charge. So here this alkyl group going to migrate to this carbon which produce this corresponding intermediate. Now you see this carbonyl oxygen has two lone pair of electron, one of lone pair of electron attack the boron atom which produce this corresponding intermediate. Now you see this oxygen get positive charge here. Now one more alkyl migration going to takes place. This time this alkyl group. So without loss of stereochemistry, this alkyl group migrate to this carbon which produce this corresponding intermediate. Now this intermediate going to react with water. So this water open up this three-member ring system. So now you see this oxygen now attack the boron atom. Now the cleavage of boron oxygen bond takes place to produce this corresponding intermediate species. Now this intermediate species undergo by basic mediated oxidation reaction by hydrogen peroxide. So before that, base readily deprotonate this hydroxy group which produce this corresponding alkoxide ion. Now this alkoxide ion attack the boron atom so which produce this corresponding intermediate. So now you see this boron carbon bond cleaved. So this electron move towards the carbon oxygen bond, which makes that carbon oxygen double bond. Now you see this oxygen get positive charge. Now this species generation takes place from sodium acetate and hydrogen peroxide. Now this O negative charge attack the boron atom, which produce this corresponding intermediate. Now here alkyl migration going to takes place. So here R means texyl group. So for our convenience, in first slide itself, we converted texyl group into R. So now this alkyl group migrate towards oxygen atom. So resulting that kick off hydroxide ion, which produce this corresponding intermediate. Now hydroxide ion attack the boron atom, which produce this corresponding intermediate. Now this electron move towards the oxygen atom, which generate this boronic acid byproduct along with our ketone product. So this is product X. So this product X in next step react with LDA. So the whole sequence of reaction is oxidation reaction. Now the product X going to react with LDA. So LDA we have already discussed about their preparation, properties and application in two parts in our channel. If anyone missed that video, you can find the link in the description box. So LDA is one of the non-nucleophilic sterically hindered strong base which readily takes the proton from less hindered side. So when you come to the our ketone, so here this position also acetic as well as this position also acetic. However, this position is less sterically crowded when compared to this position. Therefore, when we use LDA, which readily takes the proton from this side, which produce this corresponding inlet ion. Now this inlet ion react with trimethyl silyl chloride. Now this O negative charge attack the silicon atom, then kick off Cl minus ion, which produce this corresponding TMS producted enol as a intermediate. So for our convenience, we can redraw this intermediate like this. So here you should note it down the stereochemistry. These two hydrogen atoms are present at trans to each other. So now you see this conformational form. This hydrogen as well as this hydrogen atom both are present at trans to each other. Now this intermediate going to react with phenyl sulfinyl chloride. So here this phenyl sulfinyl chloride approach this TMS producted enol by bottom phase. Since top phase here you can see top phase is sterically crowded with 1,3 dioxyl hydrogen atoms. So when compared to the bottom phase somewhat less sterically crowded, therefore this addition going to takes place by bottom phase. So here you see this electron now moves here. This pi electron attack the sulfur atom by bottom phase and resulting that kick off chloride ion which produce this corresponding intermediate. Now you see this SPH group present at the bottom phase. When we convert to this structure form, so here you see this SPH group present at the bottom phase. Now this intermediate react with metachloroperbenzoic acid, so which oxidize the sulfur atom to sulfoxide. Now this intermediate when we heat, this readily undergoes Syn elimination. So here you see this pi electron takes this hydrogen atom. So this electron now moves here and resulting that cleavage of carbon sulfur bond and this electron move towards the sulfur atom. So here this elimination takes place by Syn manner, means that one of the hydrogen should present cis 2 sulfoxide group. So which produce this corresponding alpha beta unsaturated ketone as a final product. So let's moving to the our question. So as per our discussion, among the four answers, the correct answer for this question is option D. That's it for today's problem. I hope this session has helped you to understand this question. If you enjoyed this session, just give it a thumbs up and share it with your friends. And don't forget to subscribe Chem or Come for much more content like this. And finally, thanks for watching. Bye bye.